Hari Om. So last part of electricity we have seen current. So we have discussed about current. What is current? Electric current. What is electric
Flow of
current?
charge per unit time.
Flow of charge per unit time. Then we have seen what is charge. Charge is Ne, means number of electrons into the magnitude of charge. And what is magnitude of charge? What is magnitude of one electron? 1.6 into 10 power
Minus
minus
19.
19. Now there is a one thing that find out how many number of electrons are required to have 1 coulomb charge. This is also in MCQ many times they have asked. What they will ask? Number of electrons for 1 coulomb charge. So this time they have given charge. Charge is 1 coulomb. Correct? So they ask n, number of electrons. So we know that Q equals to Ne. Q is 1 coulomb. So for 1 coulomb, what are the number of electrons? N. 1.6 into 10 power minus 19. See, we have to use formula. Okay. Q equals to Ne. And you have to understand that, see, if 1 electron is there or 1 proton, charge is very, very small. 1.6 into 10 power minus 19 coulomb, very small charge. Now they want how much charge? 1 coulomb. If they want 1 coulomb charge, number of electrons will be more, right? Correct, na? So we have to count number of electrons for how many coulomb charge? 1 coulomb charge. So you can find out n, simple equation, n will be what? 1 by 1.6 into 10 power minus 19. Okay, equals to n. And we have to find this, we have taken this side. Now minus 19 will go up, it will be how much?
Plus 19.
10 power 19 by 1.6 equals to n. When you solve this, solve in the sense, see, if you remove decimal, then so what you will get?
Cancel.
10. One more 10 you take out. 10 power 19, 110 you take out. So if you take 110, it will be 18, right? So 10 into 10, 100. This 10 plus this 10 one. So 100 into 10 power 18 divided by 16 is equals to n. When you solve, how much you will get? 600 by 16 and equals to 100 by 16 into 10 power 18. So when you solve, how much you are getting?
25 by 4.
25 by 4 in decimal you tell. How much?
Six point two.
Yes. 6.25 into 10 power 80. So direct you can write in MCQ. If they ask number of electrons or number of protons or electrons for 1 coulomb charge. So how many electrons should flow to get, how many electrons should be there for 1 coulomb charge?
6.25 into 10 power 8.
10 power 18. So much it is. 10 power 18 you know, na? So much. 10 power 18. So this is the MCQ question. In MCQ many times I have asked this. Okay? Any doubt till here? Next, we will go to here. So this part we have done. So if they ask this kind of questions, a current of 0.5 ampere is drawn by a filament of an electric bulb of 10 minutes. Now 10 minutes means how many seconds?
10 minutes equals
600
600 seconds.
So simple, see, you have to just
10
use
into 6.
I equals to Q by T. So what is Q Ne? Correct?
Yes.
Find the amount of electric charge. So here just you have to find charge. And T is how much?
600 seconds.
600. Then what is current? They have given 0.5. So 0.5 into 600 equals to Q.
Q.
Simple. So Q will be how much? 600 into 0, 300 coulomb equals to charge. Charge we got. This formula is important. So first formula of this chapter is this only. Current equals to charge by time. Current is equals to charge by time. This is important. Any doubt? Now here common sense. How charge will flow? This is important. We say that flow of charge is current, right? Flow rate of flow of charge is current, or flow of charge per unit time is
Correct.
current. So we cannot control time. So time will move. That is not a big deal. But what is important? Why charge is flowing? Why charge is moving? That is important. Now, why air is moving? Because of pressure difference, right? If there is a
Atmospheric
pressure difference, if you open the door, the inside outside pressure is different, right? That's why air is flowing. Like that, water, you assume that there are two tanks of water. One is empty, one is filled. Now you connect it. What will happen?
The
Water
water
will
from
pass.
the full tank will flow into the empty tank.
Correct. It will start moving from
Higher to
high pressure to
low
Lower
pressure.
pressure.
correct. Correct. Like that only, there is something called potential difference. So we say a pressure difference. Correct. Like that, there is something called potential difference. What is potential difference? Potential difference is nothing but that how much difference is there. Okay. So battery. What is the work of battery? What battery does?
Providing current.
It provides potential difference. It will providing current and all that. Is perfect definition of battery means it will create potential difference. And because of potential difference, what will happen? Charge will start flowing from higher potential to lower potential. Okay. So here they have given definition. If you write same definition, they'll give you full marks because the answer key and all the same definition will be there. See, we define electric potential difference between 2 points is an electric circuit carrying some current as work done to move a unit charge from one point to another. So this is the definition. Actually, it is very simple. Potential difference, PD. Potential difference is equals to work by charge. Work by charge. Simple it is. Here they have given this much electric potential difference between 2 points. Why? See, difference means how many points? If I say, tell me the difference of, so any two things, right? Can you tell me the difference of one? Like,
No.
if I say difference of this, it is an invalid question. But if I say difference of this and this, you can understand, right? So difference means how many points required? 2 points. That's why they have given electric potential difference between 2 points in an electric circuit. Where? Potential difference where you measure? Here? No, in electric circuit. That's why they have given electric circuit carrying some current. Some current should pass as the work. Now here is important. Work done to move a unit charge from one point to another point. So work done by charge is nothing but potential difference. Correct? Work done. Now in 9th standard also, you might have seen that work done. What is unit of work done? SI unit of work. Joule. Correct? What is SI unit of energy? Joule only. Correct? Huh? So Joule is SI unit of work or energy. Simple it is. In physics, many of the times we use work or energy, and SI unit of work and energy both are Joule. Correct? So potential difference means some work you have to do, okay, in bringing a unit positive charge. See, you can understand in another way that suppose this is one charge here, correct? Now current means it has to move, correct? No? Current means charge has to move. So when charge will start moving from A point to B point, then what will happen? Some work has to be done or not?
It should be done.
There should be some work. That's why they are telling work by charge. What to move? What is moving? Charge. Why it is moving? Because of work. So potential difference is nothing but work by charge. Correct? Now every physical quantity have units. So what is the unit of potential difference? Volt. Volt is again name of the scientist. Okay. So these people, they have done so much for science, for physics. So we have given SI unit. Okay. Their name we have given SI unit. So work by charge is potential difference, and what is SI unit? Volt.
Volt.
Now that's all. If you understood that, now as I said, they may ask you 1 ampere, 1 volt. Okay, like that. 1 ampere, what is 1 ampere? How you will define 1 ampere?
One.
Flow of 1 coulomb.
Flow of
1 coulomb by 1 second.
flow of 1 coulomb charge in 1 second. So like that, 1 volt will be what?
1 joule by 1 coulomb.
1 volt is potential difference between 2 points in current carrying conductor when 1 joule of work is done to move 1 coulomb of charge. Simple. See, common sense. 1 volt, if you want, means numerator, denominator both, there should be 1. So 1 volt, how you will get? If 1 joule of work to move a 1 coulomb of charge, that's all. Any doubt? So this is about potential difference. So from here we got third formula. First formula, Q equals to any. Second formula, I equals to Q by T. Third formula is
PD is
potential difference equals to
work by
work
charge.
by charge. Now coming to question. See, they ask, this chapter is very simple. Very simple. But I don't know why students feel difficult, but it's very simple. Just a small formula, concept and numericals. You see this question. How much work is done in moving a charge of 2 coulomb? Charge is given. How much? 2 coulomb. Across 2 points having a potential difference 12 volt. Now in physics, any numericals you do, no? 11th, 12th, 9th, 10th, any numericals, you should first write given data. You read question nicely, write given data, write formula, aram se without any confusion you'll get answer. So here if you see how much work is done in moving a 2 coulomb charge. So what they have given?
Potential
Charge equals to 2 coulomb. Having potential difference 12. So what is potential difference?
12.
12 volt. Correct. What they ask?
Work done.
Work. Okay, use formula. What just now we have seen. Work by charge is potential difference. Correct? Correct now. So we want work. Now you just substitute. कितना है charge? 2. Correct? And then what is that? This one? Potential difference?
24 is
12. So 12 twos are? This 2 will come this side.
24.
So 24 joule. SI unit of work is joule. Correct? So 24 joule. Oh. Simple question. That's why I said. It's very simple question. Once you understand the concept, see what in physics, what else you should know? Quantity. Okay, physical, which quantity? If they have asked you work, you should know work. What is work? Correct. What is formula? Related formula. So work by charge is potential difference. They have given potential difference. They have given charge. We found out work. Simple. 6th standard, 7th standard student also can solve this if they know formula, right? Is it difficult? It's very simple. Correct. So like that, in exam also they'll ask, in board exam and all, they'll ask questions like that. See, 24 joule. Correct. Now name a device that helps to maintain potential difference across a conductor. Voltmeter. What is meant by saying the potential difference between 2 points is 1 volt? See, like that. They'll ask 1 volt. Correct? No, just now we defined like that. How much energy is given to each coulomb of charge passing through 6 volt battery? Correct. Each coulomb means 1 coulomb. So charge is 1 coulomb. Simple. See, use formula and get answer. Again, potential difference equals to work by charge. Now how much energy? Energy and work both are similar thing. Both unit is joule. Don't get confused. Here they have asked energy, what to do. Energy and work both are same thing. How much? See how much work you can do. How much energy you will have, that much only work you will do. If you have more energy, you will do more work. Understood? Huh? So actually they ask about energy. Huh? Now few students, if they don't know about work and energy, they'll think that it is new question. Formula is work, but they ask energy. You should know that work and energy both are same. How much energy is given to each coulomb? So charge is 1 coulomb. Passing through a 6 volt battery. 6 volt battery means potential difference is 6 volt. Correct? No? So 6 is equals to W by 1. So work will be 6.
Joule.
Simple. Understood? Huh? Any doubt till here? Like that, you should understand the concept. If concept is clear, everything will be clear, right? Circuit diagram and all, it's simple. You can see. Electric cell now battery. Correct? No? Battery you cannot always draw. It's not feasible. Okay, in 12th standard there are Wheatstone bridge and all, and there will be parallel circuit. We'll see here also next class. So when we use this electric circuit, we should use these symbols. So electric cell means this one. This longer side represent positive, smaller side negative. And then battery is combination of cells. So positive here, negative is connected to positive, like that. Plug key or switch, open means like this, close, open means circuit is open, means current is not passing. Close means current is flowing, bulb will glow, like that. A wire joint, like that. Wire crossing, simple one. Okay, so you can go through that. Electric bulb we represent like this. Now resistor or resistance is this one. This is a new concept, resistance. Okay, ammeter, this one, voltmeter, this one. Ammeter will measure current. Okay, and voltmeter will measure potential difference, voltage. Okay, now next class we'll see Ohm's law. Okay, any doubt till here? Simple. So we have seen potential difference, we have seen current. Next video we will see what is relation between current and potential difference. Potential difference we have seen just now. Current we have seen part 1 video, right, of electricity. So is there any relationship between current and voltage? That we will see next video. Keep learning, keep shining. Hari Om.